The transport layer uses two protocols to provide all the services, that is TCP and UDP. UDP stands for User Datagram Protocol. It is unreliable protocol and it provides connectionless service. TCP stands for Transmission Control Protocol. Hello to all, a warm welcome to my new session on the transport layer. I am your Revathi ma'am, faculty from the Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So dear student, in my last class I started with transport layer. Along with that, we have discussed the services provided by the transport layer as well as features and elements. But in my today's session, I'm going to discuss the most commonly available two very important protocols of transport layer, that is UDP and TCP. So what is UDP? That is User Datagram Protocol, as well as TCP, that is Transmission Control Protocol. These are the two most commonly used protocols of transport layer. Now see here, the transport layer is represented by two protocols. In the sense, the transport layer uses two protocols to provide all the services, that is TCP and UDP. So here T stands for transmission, C stands for control and P stands for protocol. So it is transmission control protocol. Whereas UDP, that is User Datagram Protocol. Now dear student, let's discuss what is UDP. So dear student, we are very familiar with network, and if two persons want to communicate each other, they must require the network. And how we are going to send the data and how we are going to send the data, for that we are going to have two types of connections. One is connection oriented and connectionless. Then what about connection oriented? There is a physical connection or there is a virtual connection between two device or two entity. And what about connectionless? There is no connection between two entities. Then how we are going to transfer the data or how we are going to receive the data? That is based on broadcast mechanism. So dear student, here UDP stands for User Datagram Protocol. It is unreliable protocol and it provides connectionless service. UDP is a simple and most commonly used protocol, and if I consider mobile devices, that comes under UDP. So UDP is a simple protocol and it provides non-sequenced transport functionality. So what is non-sequence? Before that, tell me what is sequenced. Sequence in the sense what? One after another. Think that I have two packets, 1, 2, 3 and 4. Okay, and if I go with the sequence, first I am going to get packet 1, then 2, 3 and 4. If I consider non-sequence, see how many packets I have? 4 packets, and I am going to receive randomly. For example, first time I am going to receive third packet, then first packet, then fourth, then second. So there is no sequence. It is a connectionless protocol. So there is no physical connection or there is no logical connection between two entities. This type of protocol is used when reliability and securities are less important. So what is reliability? For example, think that I'm going to receive some registered letter. After that, I'm going to sign the acknowledgement. So that indicates that it's the proof that I have received the letter. And if I consider normal letter, after receiving the letter, I'm not going to provide any acknowledgement. For the registered letter only, I'm going to provide the acknowledgement. And for the normal letter, I'm not going to provide the acknowledgement. So, the registered letter is reliable. What about normal letter? It is unreliable. In the sense what? There is no acknowledgement. So, here, if I consider UDP, it is unreliable and it does not provide more security. And UDP is an end-to-end transport level protocol. So it provides end-to-end transport level protocol. Along with that, it adds transport level address. So in transport layer, we are going to add the address, and it also supports checksum, error control as well as length information to the data from the upper layer. And the packet produced by the UDP protocol is known as user datagram protocol. In transport layer, the data are called packet, and whatever the packet that is generated here, and it is known as user datagram protocol. So these are the certain functionalities of UDP. Now, if I consider the frame format of user datagram protocol. So what is the length of the frame here? It is 16 bytes. It's further divided into 216 bits. So the first 16 bits are for the source port address and second 16 bits only for destination port address. So dear student, if I consider sender side machine as well as receiver side machine, each machine must have the port. To specify the port, I'm going to have the source port address and destination port address. Along with that, I'm going to have 16 bits of total length. So I'm going to specify what is the total length. For that, I'm going to have the 16 bits and another 16 bits for checksum. Okay, to provide the security, to provide the error control, error detection mechanism, I'm going to have checksum. And what is the length of the checksum? It is 16 bits, and rest of the remaining bits are data bits. So dear student, if I consider source port address, it is used to identify the individual machine uniquely. It defines the address of the application process that has delivered a message. In the sense, which entity or which machine want to send the message. And what is the size of the port address? It is 16 bits. And destination, this is the receiver side. Which machine is willing to receive the message, and what is the length of the port address? It is 16 bit. Then total length, it defines the total length of the user datagram. So the total length of the user datagram is specified by the total length. And what is the length of this field? It is 16 bit. And checksum, it's also 16-bit field and it's mainly used to provide error detection. Now, I'm going to have the TCP. So, what is TCP? It provides connection-oriented service. So, there is a connection between sender and receiver. Okay. So TCP stands for Transmission Control Protocol. It provides full transport layer services to the applications, and it is a connection oriented protocol, means a connection established between both the end of transmission. So I'm going to have sender and I'm going to have receiver. Okay, by using TCP, I can able to establish the connection. For creating a connection, TCP uses virtual circuit. So it is a virtual circuit or virtual link between sender and receiver. For that reason, it is called connection oriented. Why it is connection oriented? There is a virtual link between sender and receiver. So here there is a virtual connection between sender and receiver. For that reason, it is called connection oriented. So what kind of connection? Virtual connection between sender and receiver. Now let me to discuss the features of TCP. So here stream data transfer. So stream data transfer in the sense what? It's going to transfer the data continuously. So TCP protocol transfers the data in the form of continuous stream of bytes. So I'm going to transfer the data continuously. For that reason, it is called stream data transfer. TCP itself segment the data and forward to the IP. So the job of the TCP is to divide the data into TCP segment and transfer that to IP, that is Internet Protocol. And it is reliable. The TCP provides reliable connection. So what is reliable? There is a acknowledgement. So here receiver is going to send the acknowledgement to the sender. Once the sender receives the acknowledgement, now sender is going to send next segment. So TCP assigns a sequence number to each byte. In TCP, we are going to have the TCP segment. For each segment, it assigns the unique ID that is known as sequence number to the each byte transmitted and expects a positive acknowledgement. So what is acknowledgement? Receiver is going to send the confirmation that they have received this segment and they are waiting to receive the next segment. So that is known as acknowledgement. And there are two types of acknowledgement, positive and negative. From the receiving TCP, if the ACK, that is acknowledgement, is not received within the time, okay. So if the ACK, that is acknowledgement, is not received within a timeout interval, then the data is retransmitted to the destination. So here we are going to have the fixed time interval to receive the acknowledgement. And within that interval, if the sender is not going to receive any acknowledgement, then sender is going to retransmit the same segment to the receiver. For that reason, it is called reliable. It provides reliable connection or it provides reliable service. As well as another feature here is flow control. When receiving TCP sends an acknowledgement back to the sender indicating the number of bytes it can receive without overflowing its internal buffer. So dear student, think that I have 3 segments, 1, 2 and 3. Okay, now sender is going to send first segment. Then receiver is going to send the positive acknowledgement indicating that they have received first segment. Now they are expecting to receive next segment. Once the sender receives the acknowledgement, sender understands that they want to send the second segment. Okay, after receiving the second segment by the receiver, receiver is going to send the positive acknowledgement and this process is going to continue. So here we are going to send this segment one after another. So here we are going to have the flow of control. We are going to control the flow of the data. So when the receiver receives the TCP segment which is sent by the sender. Okay, so all the data are stored in their internal buffer. The number of bytes is sent in the ACK in the form of highest sequence number. So, for example, first sender is going to send the first segment and receiver is going to receive the first segment, and where they are going to store the segment in their buffer, in their internal buffer. After storing, receiver is going to send the positive acknowledgement indicating that they are expecting next byte, that is next segment. So which is the next segment? That is the second segment. So this mechanism is also known as window mechanism. So this process is known as window mechanism. Another very important feature here is multiplexing. Multiplexing is a process of accepting the data from different application and forwarding to the different application on different computer. So in multiplexing, we are going to accept many inputs from many devices. So we are going to receive the applications from many devices and we are going to combine the application in one single application and we are going to transfer, and at the end I'm going to extract all the application, or I'm going to separate all the application, and that process itself known as multiplexing. At the receiving end, the data is transferred to the correct application and this process is known as demultiplexing. So at the receiver side, I'm going to have the demux. And what about sender side? It is multiplexing. That is nothing but the mux. So what is the job of mux? It's capable to receive n number of input and generates only one output. Then what about demux? Demux is going to receive one input and it's going to generate n output. So this is also one of the feature of TCP. Now another one, full duplex. So what is full duplex? It is transmission mode. So sender is also able to send and receive the data simultaneously, and receiver is also capable to send and receive the data simultaneously. So TCP provides full duplex service. So the data flow in both the direction. So if I consider sender and receiver, the data flows in both the direction. In the sense what? Both the parties are able to send and receive. So it is two-way communication. For that reason it is called full duplex. Now I'm going to have the segment format. So in TCP we are going to consider the packet as the segment, and this is the segment format. See here, the 32 bits are categorized into two different parts, that is source port address and destination port address. And what is the size? It is 16 bits and it is 16 bits. Now, if I consider sender side as well as receiver side, I'm going to have the machine or computer. Okay, now in each computer there are n number of processes. To identify individual process, we must have the port address. Okay, so that port address at the sender side is known as source port address and receiver side is known as destination port address. Okay, fine. After that, I'm going to have sequence number. The data segments are identified only through this sequence number. And what is the length of the sequence number? It is 32 bits. Now, I'm going to have the acknowledgement. Based on my sequence number, I'm going to have the acknowledgement. So, what is my sequence number? It is 32 bit. Obviously, the acknowledgement number is also 32 bit. Then, the first 16 bits are classified into 4 bits of header length. So, header length holds 4 bits and remaining 6 bits are reserved for the future use. Now, the size of the window is 16 bits and it provides the checksum. What is checksum? It's an error detection method or it's an error detection mechanism. And what is the size of the checksum here? It is 16 bits. And I'm going to have the urgent pointer. And what is the size of the urgent pointer? It is 16 bits. And at the end, I'm going to have the options and padding. Dear student, from the examination point of view, both the UDP and TCP segment formats are very, very important. Now, what is source port address? It is used to define the address of the application. Address of the application in the sense what? It is sender side machine port address. Then destination port address. It is the receiver side machine port address. To identify the machine, we are going to have unique port address. So, it is destination port address. And what is the size of sender port address as well as receiver port address? That is 16 bit. Then I am going to have sequence number. Here TCP is responsible for sending stream of data. Stream of data in the sense what? Continuous segment. So a stream of data is divided into 2 or more segments and the 32-bit sequence number field represents the position of the data in the original data stream. Okay, so the streams are divided into number of segment and 32-bit data or 32-bit sequence number is used to represent the position of the segment in the original data. And I'm going to have acknowledgement. So what is the length of the acknowledgement? It is 32-bit. And where and who is responsible for acknowledgement? That is receiver. So 32-bit field acknowledgement, that is acknowledge the data from other communicating device. If ACK field is set to 1, then it indicates that the sequence number that the receiver is expecting is received. In the sense what? If the ACK is 1, that indicates that it is positive acknowledgement. In the sense what? It's already received by the receiver and expecting next segment. And I'm going to have the header length. It specifies the size of the TCP header. To specify the size of the TCP header, I'm going to have TCP header length. And what is the size? It is 32-bit. In the sense what? The size of the TCP segment is 32 bits. Okay, in that I'm going to use only how many? 4 bits. I'm going to use only 4 bits. And remaining 6 bits are reserved fields. And I'm going to use these fields for future purpose. And the last one is control bits. So here each bit of a control field functions individually and independently. A control bit defines the use of segment or services as validity check for other field. These are the very important fields of TCP segment format. So dear student, if I consider TCP as well as UDP, both are the protocols of transport layer, and UDP provides connectionless, unreliable, less secure communication service, whereas TCP provides connection oriented, reliable, secure connection. And from the examination point of view, both the topics are very, very important. And in my next session, I'm going to deal with internet transport protocol. Anyway, dear student, let's meet in the next session with the new concept, that is internet protocol. Until that, keep watching and keep learning. Thank you.